Okay, the last thing that we're going to look at is continuously compounded interest. Very interesting that E, the number E, actually shows up when we're dealing with compounding interest. So the formula that we're going to use is this one right here, A equals P times E raised to the RT. P is your principal amount or your original amount that you're investing. R is your rate. And then T is your time in years. Okay, so that's what we're going to use. So coming down here, there are three parts to this problem. We're going to do all three parts. When Angelina was born, her grandparents deposited $3,000 into a college savings account, paying 4% interest compounded continuously. Assuming there are no deposits or withdrawals from the account, what will the balance be after 10 years? So if they don't deposit any more money, how much will she have after 10 years? So we're going to use this formula. A is what we're solving for this time. P, that was our initial amount that we're investing, which in this case is $3,000. R is your rate. So if I'm dealing with 4%, I need to convert that to a decimal. That is 0.04. And I want to know how much am I going to have after 10 years. So T is 10. We can plug all that in. A equals P is your initial again, so 3,000. E is a number, so it stays in there. Remember, E was approximately 2.718 raised to the 0.04 times 10. This is where you can take your calculators. We'll do the same. If I plug this in, I got to move this out of the way. There we go. I'm going to clear this. I've got 3,000 times E raised to the, some of you might need to put parentheses around this. My calculator does not make me do that, but just so you know, some of you might have to do that, times 10. Oops, I don't need parentheses, just as I said that. Oops, and now I made a mistake. There we go. Back on track. Gets me, since I'm dealing with money, we're going to go to two decimal places. So 4,400, and I got to find my answer on here again. Ooh, mine was very wrong on my sheet. Let's try this again. 4,475. 75 and 47 cents. Okay, that's the first one. Second one, how long will it take the balance to reach at least $10,000? So I'm still using the same information up at the top, still going to use the same formula. I'm still investing 3,000. E is just a number. My rate is still 4%. This time I don't know what T is because they want to know how long. That's what I'm solving for, which means that A should be 10,000. Okay, if I plug that in, now I've got 10,000 equals 3,000 E to the 0.04 T. This goes back to some examples that we did earlier, example 4 actually. We want to get E raised to all of this by itself, so I need to divide both sides by 3,000. And if I divide by 3,000 out of this, I'm not going to completely divide it, but I will get my numbers a little smaller. 10,000 divided by 3,000 actually simplifies to 10/3, equaling now E to the 0.04 T. Remember, to get T down on the same level, we're going to take a natural log on both sides. That allows me to pull my exponent out front. So natural log of 10/3 equals now the natural log of E to the 4% times t, which allows me to now pull the exponent out front, equals that. And we know from before that the natural log of e is just 1, so that goes away. I'm going to do one more step. To solve for t, we're going to divide both sides by the rate. So now t over 0.04, that will get me my time t. If we plug that in, I'll let you guys do that, but it comes out to approximately 30.1. Remember, t was in time in years, so about 30.1 years, it will get to 10,000. Okay, and the last one. This one says, if her grandparents want Angelina to have $10,000 after 18 years, how much would they need to invest? Still using this. Okay, so now I need to figure out how much are we investing at the beginning. I want to have 10,000, so A is going to be 10,000. My rate is still 4%, and I want all of this to take place in 18 years. So plugging this in, now I have 10,000 equal to, trying to figure out what P is, times E to the rate of 4% times 18 years. We're going to plug this all in at once. Remember, E is just a number. So I've got a variable P times all of this as a number. You can plug that in if you want right now, but I would recommend plugging it all in at once. So to get the variable by itself, to undo multiplication, we're going to divide all of this over to the left side, giving me now 10,000 divided by E to the 4% times 18. And that will equal how much I should invest right away. I better do this one, as my first one was completely wrong as well. So I'll pull out my calculator. I've got 10,000 divided by, I'm going to put parentheses this time, E raised to the, again, you might need parentheses here. My calculator does not. Like so. And it looks like we would need to invest $4,867.52. So $4,867.52 would be how much I need to invest in order to get 10,000 in 18 years.